So thanks for coming, everyone. I'm Max from ERM, and I'm happy to introduce Sebastian Hubert, aka Highboyd, to you. He's going to present our multi-clock synchronization solution. And yeah, I think he's giving a vibrant presentation.
Thank you, Max. Hello, everyone. Welcome to Superbooth. I hope you're enjoying yourself and having like a little tech presentation here with some music. Okay, I'm going to present to you this box. This is the multi-clock by Erfindungsbüro Rest und Meyer, complicated German word, ERM. That's the abbreviation, so we go by ERM as well. So what does this thing do? This little box is a multi-purpose synchronization and conversion tool. It links your digital audio workstation. I'm going to refer to that as a DAW from now on. So it links your DAW to all your hardware, your gear, your outboard, sound generators, sequencers, drum machines, effects box, name it. You can connect it. Because you know the situation. You have all these little modulars, semi-modulars, or drum machines, and you don't really know how to get them played together because some have old synchronization standards, like pre-MIDI standards. Some have only analog inputs for clocking. Some have MIDI inputs. So what are you going to do about it? You just want to have one common clock to synchronize all your gear together. So this is what the multi-clock is for. It takes a clock signal from your DAW and converts it into all kinds of different clocks and distributes it through its 4 outputs, which are here on the back. So you get one input, 4 outputs, 4 output channels. Each output can have different clock formats. And you distribute these clock signals to your different hardware, like your outboard gear. So you know that when you have a MIDI master device, in this case, the DAW, there's never really like a tight MIDI clock due to sloppy driver programming or like overall MIDI engine in Windows sucks. So you will always have like jitter and inaccuracies. And in order to overcome that old perennial problem that's been going on for like 20, 30 years even, the multi-clock locks to a sample accurate signal. And that signal is a little plug-in that you can simply drop into your DAW, VST or AU plugin, and this plugin generates little ticks, little clock signals, trigger pulses. Namely, technical detail, 24 per beat. That's the same resolution as MIDI clock and DIN-Sync and various other old analog clock signals for old drum machines like Lindrum and stuff like that. So you're going to be able to send that's what you need. You need an audio interface that allows for separate outputs. Because what you will need is you will just plug in a lead into one of your audio interface's outputs, plug it into the back of the multi-clock, and off you go. Then the multi-clock locks to this clock signal and outputs all kind of different clock formats. So I've set up this little board here with a typical live setup. So we got different things here. We got a Roland TR606, which takes DIN-Sync. We got a DSI Evolver, which takes MIDI clock to synchronize its sequencer. And we got a little skiff here and a little semi-modular. So this stands for, like, this is symbolic for your Eurorack system or whatever modular you're using. So these are 3 clocks, and now there's a 4th one. I mentioned a 4th one, and that is a LFO. You have an analog LFO on channel 1, and you can synchronize this LFO to your master clock. So now enough talking. I've set up my DAW to output a bass drum. This bass drum is an audio file, so this is output like via my audio interface. So as you can see here, I hope you can see it, the multi-clock is in sync with the DAW. So here the LED is blinking, that means it's locked in. So the multi-clock is now generating clocks, and it's waiting for me to output these clocks. So I have these mute buttons here, like channel mute buttons or activation buttons. And if I want to activate my Roland 606, I activate this little switch. And off we go. We got a little pattern here. I don't like this one. I'm going to use an offbeat hi-hat. So now what we got is a bass drum coming from the DAW, this one, and a hi-hat from the 606. So now we are talking super features on the multi-clock. Two super features that set them apart from many, many other clocking solutions. So one feature is you have the ability, the option to shift the clock signal in time, forward and backward. Meaning you can add an offset to the clock, a positive one or a negative one. So why would I want to do that? Well, if I got a sequencer or a modular system that introduces a certain lag into my audio flow, some delay, it might just be a couple of milliseconds, but you will have the feeling that it's not in sync. You know, there's flams on kick drums and flams on snares, and you know, everything just seems to be falling apart. So what you want to do then is to introduce a negative delay in order to shift the clock signal forward in time, meaning the modular system or whatever you're synchronizing gets the clock ahead of time, and that means it will be in sync, it will be on the beat. So in this case, I'm going to show you the offbeat hi-hat. I want to have it like slightly laid back. You see? Now I can play with a groove. I can do like I can introduce like a little lag. So, and I can do it. No, the swing is that's another story. So of course I can do stuff that is not musical in this context, but you've got plus minus 300 milliseconds of delay. So that, depending on the BPMs you're using, can mean up to 1/8 note of shift. So you can move a pattern plus minus 1/8 note. So that's pretty cool. So now I'm on delay is 0 again. I'm going to introduce some more notes here, so you can hear the effects of the swing that I'm going to introduce now, because you have got a shuffle parameter on the multi-clock. The TR-606 doesn't have shuffle. It's straight. It's always quantized. So what you will do now is you can shuffle the clock. That means if you've got any sequencer, any old drum machine, any arpeggiating synthesizer that has a straight clock, you can just shuffle the clock and you can make your synthesizer and your sequencer and your drum machine swing. So I'm slowly introducing some shuffle here. Now I'm at 50% shuffle. This is like 70%. Now it's getting extreme now. 99%. So this is the max you can go. But you see, this is that's quite shuffle. So I'm going back to like a 20-25%, which suits my taste. Okay, so that's the shuffle in DIN sync. So now I mentioned analog pulses, analog triggers. So I will now introduce my little modular system here. So I've got a very, very simple patch. It's just a one oscillator bass line. This whole little setup is being fed by channel 4. Like one output of the multi-clock is now accounting for all the clocking that is going on within this little system. So I'm distributing the clock signals here with a multiple and distributing it to various other modules, and including one little trigger sequencer that opens my envelope here. So I can now go and shift this clock signal in time, make it lag. You see it starts getting audible now. So if I'm going to do this very subtly, now I'm adding 10 milliseconds of delay to gives it kind of an interesting feel. And I can introduce some shuffle as well. Getting more organic. It's losing its static, quantized sound. So this is what we can do with just one clock signal. It's driving this whole modular thing. And imagine you've got a Eurorack system, like a huge, it can be a small one, but even if you have like a huge modular system, you can use the multi-clock to drive all your modular sequencers and trigger generators, whatever you use. And you can introduce shuffle and delay into each of these 4 clock signals, which gives you a variety of options that you can make your modular system groove, if you will. One important thing that I haven't mentioned yet is that the multi-clock is not only operating, let me bring this down for a minute, cannot only operate as a slave device, but it can also generate its own master clock. So if you don't want to use DAWs or laptops in your live setup or studio setup, you can simply just use the multi-clock as a master device and it will produce an ultra stable clock. So this could be your modular master clock. Just put it on a little stand aside, connect the wires, and then off you go. You will have a very, very, very accurate clock source with various clock divisions, which are available individually for each channel, and with the ability to shift the clock signal in time and to introduce shuffle. So now we got another neat feature here. That's the analog LFO. So I will show you what the little analog LFO does. I will close the... I'm now circumventing the VCA, so now we got a steady. So I'm now activating the LFO. So you might notice that every bar, in the beginning of every bar, the LFO resets. So this gives you a repeating rhythmical pattern to the bass line. And of course I can change the LFO rate. It goes into the low audio range, but it can also be very, very slow. And you can see that it repeats periodically. Now I'll simply add some envelope modulation to it. You've got more different waveforms available for the LFO. You got rising and descending sawtooth. You have sine wave, square wave, and random wave, which acts like a sample and hold circuit. And in this mode here, I'm freewheeling, so I can determine the frequency seamlessly. And there's also a mode called quantized, where the frequency is quantized to rhythmical note values, like a bar, half a bar, the quavers, semi-quavers, whatever you wanted, triplets. Triplets, yes, no, Max? Triplets? Triplets are in there as well, yes. Okay, so that's the LFO. And now we've got one source missing still from our little setup, and that is a MIDI clock. So I brought the Dave Smith Evolver here, and it takes MIDI clock for its synchronization. So I'm gonna activate it. And now you're hearing a typical Evolver sequence. So far so good, nothing fancy. You won't hear the effects of shuffle in this context because it's set on 8th notes, so it's pointless to show you shuffle here, you won't hear it. But what I can do is I can shift the signal in time. So I've set up the delay in a way that it has a maximum range of 120 milliseconds, which gives you 1/16th notes. So you might notice that the sequence is now on the offbeat. So I can use it for musical purposes as well. It's not only like a technical thing that I can compensate for errors, for inaccuracies in synthesizers, but I can also use it in a creative way. In this example, 120 BPM, that's easy to calculate. You just have to calculate how long is a 8th note or 16th note, set it up, and off you go. You can shift your sequence in time on the go, as we go. Okay, so how about using the delay parameter for perceptual correction of a sound? I will now change the sound in a way that makes it difficult to mix, because I'm gonna add a long attack phase. Okay, so the sound seems to lag behind because the attack phase, like the sound fades in gradually and lags behind. So what I can do now is I will introduce a negative delay to this track. Thirty milliseconds. And you hear that it's now fitting in the beat. If I move the delay back to 0, you can feel it's lagging behind slightly. And now I move it forward in time. Now it's on the beat. So now let's bring all sources together. Got all instruments playing together. I have failed to mention one very interesting feature. That is the mute buttons. I can simply mute my instruments by simply muting the clocks. So I can stop the clock from being distributed. So what? Imagine this scenario. You're doing a jam session and someone's late. So, and you have your master clock running and someone brings his TR 606, 808, 909 with him and he connects it. What happens? Normally, you've got like a MIDI network and you convert your clock. This thing won't start because it's not gonna start in sync, at least. With DIN, it will start, but it will not start in sync. So what can you do here? I'm gonna switch this off. So I bring this box, plug it in, and all the others are playing. And now I want to have my 606 run along. I simply activate the channel and it starts running on the beat, on the first beat of the next bar. And if, like the Evolver, you have a synthesizer that sometimes hicks up during loading a patch or changing system parameters and loses sync, because the DSI does just that. If I load a different patch in a live jam, I screw my setup because it's gonna drop out of sync. So what do I do? See? It's out of sync because it dropped some beats, some ticks. So what I do now in a live situation is I turn the channel down. I don't have to stop my master. I simply deactivate the clock for 1 bar, switch it on, and it's in sync. That's a lifesaver in a live environment. And if you are like me and you get like a blackout and you think, wow, that's a cool sound, I want to save it. Don't save it on the Evolver, it's gonna hiccup and you're screwed if you are running to a master clock. So that's a life-saving aspect of it as well. Okay, Max?
Thanks, yeah, thanks Sebastian for this really great demo. I hope you all enjoyed it, and if you have any questions, just come over to our booth. It's in BS 440, and we will try to answer them. Thanks, have a great time.